I think we're going to jump right into Kubernetes the hard way or the fast way, or a mix of the two. By show of hands, who has set up Google Cloud Platform, whatever? Who didn't then? It looks like almost all the hands went up. You haven't had a chance yet? Do you have the link? Are you in Slack? It's on the Meetup page. There was a tweet that Google promotes over and over from about May, where you can sign up for a $300 credit to Google Cloud Platform. If you clean this up before you leave in an hour, and you just want to pay with your credit card, it might be somewhere in the realm of $5. But $300 free, super awesome. So let me know if you don't find that link. Okay, so everyone else has Google Cloud set up then. The next piece, once you have it set up, is one of the other links I put in Slack and on the meetup.com. I think I did them in Meetup notes, is where I'll probably throw a bunch of stuff today. So if you're in the Slack, it's the Kubernetes hands-on tutorial from my GitHub. Nope, it's actually this one, the Kubernetes scripts. The README on this, Tom, you said you were able to follow this, and it was lucid, or?
I made a couple. I made only one change. You're downloading the control binary manually.
Uh-huh.
You have to install it in the cloud.
Okay.
Google Cloud will install that, so that
Will you make sure to bring that up when we get to that? Is it like the first thing, or?
yeah, it's like a G Cloud components installed for control.
Uh-huh.
Instead of like the, so
For the most part, I took Kelsey's, so what we're working with tonight is Kelsey Hightower's Kubernetes the hard way. If you haven't seen presentations that Kelsey Hightower gives, you should. They're awesome. He does ones where he talks to the OK Google thing and like brings up a whole Kubernetes cluster. Plus, he's a really good speaker. I just took the commands that he ran. He did it as no scripts. He just said, run these commands and bring it up the hard way so that you learn like how things fit together. So we're going to do it the hard way and talk about those things, but rather than having a room full of people trying to copy and paste and possibly get them wrong, because there's about like 1,000 commands or whatever, I've got it down to copy and pasting about 10 or 20 times. Does anybody else try it out? Cool. Did you get Google Cloud $300 credit? Still happening?
I sent a tweet, but there's a link right below. You click on the image.
So let me click on this.
yeah, basically, I just went straight with it. Just right here.
Oh yeah, they might just give it. It's not.
It was not.
Yes, I don't remember. Just that is if you've done this before, like more than 6 months ago, then you had it.
That's true.
Or 12.
Yeah, so 12 months and you get a $300 credit. When we get into my account, you'll see that I've already used like $100 of it. So rad. Next. What's that?
So I wonder how much second sequence.
I don't know what the monetary value of SecKC coin is yet. It seems like you can get really
Pretty
cool
good.
stuff at the meetups. Okay, and then this was asked earlier today. How many people are on Windows machines? 1, 2, 3. We got 3 possible. Was it 4 in the corner? Were you on Windows too? Okay. I just linked to the quick start for Mac OS X, but I think there's a 4 Windows here, and you'll need to install this SDK. What's that? Sorry. Oh, are you guys unable to connect?
Make sure you're not using DNS from Google.
Yeah, they block DNS. We have to use theirs.
That's a good point. Is anyone else not connected to the internet? I saw some chatter, but I thought people had figured that out. Cool. By show of hands, who has the SDK already set up? Looks like about half. Who doesn't? I'm assuming the other half then. No? Who needs to walk through getting the SDK set up? No one? Yeah, you do?
Sort of, it's set up, but I keep getting errors when I find a list of resources.
You
Okay.
may have to validate the event.
Yeah, connect the project.
So we saw some of this today in the general room.
I'll post there.
Where was that? Somebody posted getting some kind of error like this. Some requests did not succeed because it's not found on the API calls. If you did this recently, is that what you're getting? I saw this a lot.
I can't really read that, but it sounds like
Okay,
It's like
that's right.
There's a link, and if you click on it, it'll, at the very top, it says enable Google.
There was a case also where I named it the same name you named yours.
Yeah.
Like, Kubernetes out there, and I got that dash Aaron. And it gave me, it said I didn't have permission, so I had changed the name to one that I thought was more unique.
Is it? I was wondering that when I did this. Is it unique like an S3 bucket name? Like,
Seemed, at least for me, that's how it acted. I had to do it again. So I did the G Cloud in it, and it had different options. Yeah, like option 2 to change the configuration of the whatever it was, the default. I renamed it.
okay. So if you can't do the list command yet, anybody not able to do the list command, then you'll need to go into the Google Cloud thing and cancel this. And if you'll need to put into context whatever it was that you did when you started things up. So maybe it's this one, and go to Home, no, API Manager. And either enable API here or library, compute engine API, and then there should be an enable button here. Mine says disable because that would be the toggle. It says it the direction you're going. Did you get connected, Tom? DNS was it? Did anybody else have that DNS issue? Tom knows how to fix it now. Are you on with a Google account? Did this help you with your list?
I think so. I enabled the API. I'm just waiting to see if it's
Hey, Aaron, this is Adam. I just had a quick question. Is there any way you can
Share
screen? That way the recording won't be from over your shoulder to the projector.
I meant to do that already.
You're all
Thanks.
right.
How's that?
That looks gorgeous. You can full screen it. That's good enough, I think.
Okay,
I'm sure other people can comment. They can see it on their screens.
awesome. The Cloud Shell built. Oh, let's take a look at that.
That's the way I did it. You come up to where your face is,
Yeah.
and then go over like 5. There's like a little command line icon. It's like a
Here.
left, formal left, formal. There. And it brings up a shell on the back.
Oh, that's super rad.
basically a
This might be good for the Windows people. then, right? To use this as your Unix-like connection.
The shell thing.
Yeah,
I'm
sweet.
still not able to list the shell works.
Okay.
You were able to enable though?
Yeah, I enabled the API, but I mean, maybe it still needs some time. But it's,
It does take a minute. Some people were sitting there for like 30 minutes, and it doesn't take that long.
I did a little bit of shell I guess. Oh my God, it's GitHub right here.
Okay, so in the Meetup notes, this GitHub link, does anybody not have that like Git clone to their machine or need help cloning in Git? Don't be shy. Like, so in the Slack, it's the last one before they start expanding out all these, or it's this one down. It's the last one here. So, does anybody not use GitHub before? Honestly, don't be shy.
Which Slack channel are you?
I am in the DevOps KC team, and there's one called Meetup Notes. Because General is getting very chatty about like all kinds of stuff, I moved. What's that? Which is great. No, by all means, continue to have all kinds of conversations. Don't ever hold anything back. But I just figured the Meetup Notes channel would be a good one. Now, is anybody not in the Slack? Not in the Slack? You can invite yourself if you go to DevOps KC in your browser, DevOpsKC.Heroku app. Heroku is HEROKU.com. And then you put in your email address. We'll send you an email, and then Slack does this really cool stuff with magic links. So you, once you create a password, that you don't have to sign back in if you use the client or your phone or who and the what now and whatever.
How do we join the channel? I'm trying to. It says I'm creating a channel. Oh, we're creating.
Okay, so in Slack, if you are in one like this, so a lot of times you naturally want to go over to this plus button here. If you just click on channels, which is kind of hidden,
No.
and type Meetup, there's a Meetup Notes channel that you can join.
Okay.
A whole bunch of people are joining. That was a great question. See, don't hold back any questions. Somebody else has them. What's that? DevOps. Never done that.
You're not part of it.
Now I'm interested. DevOps.Heroku app.
Caveat, I just got library Wi-Fi blocks outbound for 22.
Oh, does it really?
I think that if you go through the Google Web UI to SSH in the web terminal, rather than actually.
So we're not going to be able to SSH on unless we
Second CVP, let's use the web.
Good to know.
Yeah.
Well, that means I'm going to have to go. Cool. For those who haven't used GitHub before, I probably use it wrong, and I'll probably learn something from way better ways that you do it. If you go to that URL, github.com, the Kubernetes scripts and everything that's in the Slack, if you go over here to clone or download, the green button, and then, well, I guess we're gonna have to use this anyways. It's git clone that repository. Don't be shy. Anybody not get what I did there? Cool. You're able to get on here at least? Rad.
Yes.
Now, this console one, does anybody know, does it have Kubernetes on it, or do you need to I have not done this part. Do we just dev install the? Is it just a Ubuntu box? Yeah.
Pretty sure Kubernetes.
How would we know?
I don't know that.
Kube control -- version.
Yep.
It's on there.
Yeah, I mean, at least knows what it is.
Or which kube CTL. So for Windows people, if you want to check and see if something's installed, I don't know if Windows has something like this, you can just say which, and then the name of the thing, and it'll tell you where it's installed, or you usually do -- version, sometimes -v, sometimes -sv, sometimes version with no dashes. Rad. So I assume that this would be in context of some project. No, it wouldn't be yet. Would it be? Would it be in the context of this project here? I bet it would. So I bet we don't need the setup at all.
I was able to SSH, but I had the VPN to my work. So that.
Yeah. So do we want to do VPNs, or do we want to do the Google console thing, or I don't care. Yeah. That way it's tested at least. This is going to be fun. There are none of those, but shoot.
I noticed there's a part where you're using the weekend for basically most of it. Well, okay, it says here you want to use for basically like a managed Kubernetes.
We wouldn't want to install it. We wouldn't be doing the install, but it's
Yeah.
The hard way got a different goal. So it's what your goal is. The thing about the hard way you what the components of administrator and some examples on how to configure security. It's not actually something you should ever do.
But basically, learn to do the hard way, then we can use it.
Exactly, yes. So if you ever want to do Kubernetes for real, say on Amazon, your local system, do something like DevOps, or there's a couple of installation systems. On Google, I definitely recommend using a hosting. Even once with this whole, even if all the hardware all the way to completion, there's still like 7 different. For example, if you get it from Google, it'll automatically hook up to Google load balancing, Google disk storage, Google logging, Google monitoring, right? So these are things that are going to be different based on which cloud provider or physical system you're in. Right? So the generic Kubernetes is going to be trouble a lot, I'm sure. Depending on where you install it, you're going to be F5, Linux, reps, or HA proxy, or whatever.
Basically saying that this VM and stuff.
It's
It kind of, Kubernetes kind of like divides up and has this philosophy that there's going to be a set of cluster operations people who are running the cluster. In the GKE business, you delegate that to people. Possibilities. And then sort of application level operations are separate people. Also be separate a little bit. Yeah, I think the cluster op story, like GKE, basically they do it on AWS or maybe like GCE like this, like can be pretty fidgety right now. And then the other thing is that they're really trying to prepare you for is if you want to run on sort of you can't just sort of script it out. So you have to know about all the pieces and how they are. That is probably pretty rare nowadays. that you need to be doing that. But this tutorial is really specifically focused on cluster operations. I'm preparing you to install or administer the cluster more so than it is focused on distributed system.
somewhat important. Kind of assumes that you know why you want versus doesn't really talk about that. It's just assumes you know what you're doing. Yeah, it's kind of it's called the hardware.
Two meetups ago, we had someone come in from Red Hat and talks about Kubernetes and OpenShift. It was called Kubernetes and OpenShift the hard way. His explanation was great. Kubernetes is like the kernel, and to him, OpenShift was that operating system. That operating system, just like in the real world, like Linux is the kernel. Everyone builds on that, and they've got all these different distros or whatever, like Red Hat, Ubuntu, or whatever. Your operating system could be Google Cloud Platform. It could be AWS. It could be a number of things, but like Kubernetes kind of is that core piece. So tonight's thing was really to kind of like get an idea of like how these pieces fit together and building on that other thing. The feedback I got from that was that people were like, that was awesome. Like the things that were done with OpenShift and Kubernetes. However, I don't get it. Like I haven't been able to get my hands dirty and actually like try it. So this was an attempt to like, just kind of dig in. So I don't know, maybe it's not appropriate for everybody because like this is the cool part about DevOps is like some people are going to go on and be developers after they leave this room and they're like, I don't care how it gets set up. I'm just going to run a command and deploy something. And some people are going to, this is going to be their job. Like, like at some point, if Kubernetes continues on the track it's on, this is going to displace like a lot of the ways that we deploy by other means or whatever. So.
Another thing too, even if you are a developer, camp and you probably don't care that much about the guts of how Kubernetes work, the abstractions right now are not perfect. So
Yeah.
sometimes things are going to be broken, and the only way to understand why they're broken is to know about how the controller manages the guts.
It reminds me of when I was in college and we would try to like, build the operating system with the Linux kernel and like try to get like, take pieces from different places and get it actually running on, our Windows machine that would be broken for 4 weeks because we couldn't get the thing running. And then eventually we had like command prompts and we're like, sweet, I still can't do my homework on this.
It's kind of like when you're trying to write like a Rails app and you end up tracking down the kernel's dependencies.
Exactly.
Because
All right, I'm gonna try to play the role of the gas. You guys are gonna play the role of the brakes. You're gonna tell me to stop, I think, and tell me if I'm wrong. We've got people ready to go. We have a Google Cloud account. You're where I'm at. I'm gonna try to do this time. This is learning for me. I did it on my local machine last time. I'm gonna do it on this thing.
So the scripts, we're not gonna type it out, we're just gonna use the scripts to
So
go through it.
So what I did is I'm on that console on Google Cloud. Someone showed me how to get there. If you're not there and you want to be there on your Google Cloud platform where I have $100 left of my $300, you can click on this little command prompt thing up here-ish, and then this pops up down here and you can run stuff. You don't need the setup stuff that some people were having a problem with because I just did Google Compute Instances List. And my assumption, which we'll see if it's right or not, is that you're in the context of this, which that setup stuff was just putting your local machine's SDK in context of this. Not just, it was doing a bunch of other stuff, it was installing binaries and this, that, and the other. But the thing what it was doing was putting in the context of this up here. Anybody need more time? Okay. Oh yeah, so then the other thing I did on here was I just, oh, it's actually up higher. I just did a git clone of that github.com/AaronBlythe Kubernetes scripts .git. So the first thing is to get the infrastructure up and running. I'm going to, before you guys go run this on your account, because I don't care, I'm going to spend all $300 of this to try to learn Kubernetes. Looks like it'll work. Just grab random scripts off the internet from people you kind of trust and run them on the cloud. Why not? But let's talk through what Kelsey had in mind for this first part of the lab. Is that you get 6 VMs up and running. I think there was a question earlier that I don't know if I understood because I don't understand things very well. And I don't think I could answer it. But the thing that's been blowing my mind is there's VMs still here. You feed VMs to Kubernetes, but then Kubernetes cuts those VMs up into, is it pods or kubelets? And then on those you put containers. Someone can explain this better than me, right? So go for it. Okay.
In Kubernetes, it's all Docker, but primarily Docker. And pods are a collection of connected Docker containers that share a single network namespace. So different pods hit each other. So pods is just a kind of collection of Docker containers. So there's no VMs inside. It's all outside. It's either run on bare metal or and then they would be run on.
That's the analogy for so a container is like a single thing that's immutable that you have a release channel for. So your particular application you're building only has container versions, but also like some upstream tool you're using like that. pod is a bundle of a set of those containers that run together, the same machine, same network namespace, so they share like the local host network. They can also share some bind points, so they can share a file system between containers, so you can have like one container image that's building HTML files, another image that's building around this network. So the pod, I think the closest analogy, I think, is like traditionally like a chef environment, but it's a machine. If you have a machine runs like primary workload and also runs like sort of ancillary workloads that are just processing on the machine. A log shipper, metric scraper, stats like all those kind of like ancillary sidecar kind of things. In Kubernetes, you can still bundle them together. But having them as separate container images means you can think about the versions of all the components really separately. You don't have to build them all into a single container. In other words, like every time you release a new version of your monitoring agent, you don't have to then go rebuild all your application images to that new monitoring agent. You just bump the version of the monitoring agent, create a new pod definition, and roll out that. Doesn't make any sense at all.
Yes, it made sense, but I think it's also it's hard to conceptualize until you've done it.
It's pretty similar to how you traditionally use it. I think the main benefit of doing these things with containers versus VMs is EC2, especially VMs, take a couple of minutes to boot. It's really hard to get a couple of minutes. Versus pods can be up in like 3 or 4 seconds.
I think that's the key value proposition, right?
It's kind of crazy like how much that time difference matters, like just practically, but it really does make it feel so much nicer. Yeah.
Whereas traditionally you might say, oh, I have one EC2 and it's where I would put one.
You can, because it's basically more efficient because they, like a container is, you know, the UX around it is kind of similar to working with VMs, with snapshots and disk and stuff. Really, it's just a fancy CH group, basically. It's a fancy on the same host. Just like some security implications, but for a lot of environments that doesn't matter. You win a lot.
Cool. So this first script from Kelsey, if you just go run this on this thing, it appears to work. I've got 6 machines up and running. And the end result of what you wanted us to have was those 6 machines up and running. So from the explanation, like kind of pare it back, what I think I heard from you guys is you don't really give VMs to Kubernetes, is you got to get VMs up and running. So we haven't done any Kubernetes stuff yet. We've just got 6 VMs. We named them controller. We're going to build the controller plane and workers. So since this is an HA type of setup, Kelsey is very clear in the README that don't go run your production on what you're built here, but there's a lot of good ideas here about what you should do in your production if you were going to administer this yourself, because you're going to try to make it HA and have that failover type of thing. So in running this, I've got 6 VMs. Sweet.
Which script did you do?
I simply cloned that, and then I'm following the README. So the README out here online, I just did the 01 scripts /scripts 01 infrastructure GCP.sh. This is on the one that I was talking about cloning. It's github.com/AaronBlythe/Kubernetes scripts. Are you in the Slack? It's easiest to just click on it, but AARONBLYTHE. I've been doing that for like almost 40 years now, so I just do it really quick. So. The next one might be neat because I just assumed I'd run it on a Mac.
Is Loop a euphemism for sharing?
Sure. So what he wants us to do instead is W get these ones. Are these the ones you did different or no? I think if I just grab those two pieces and then run my Mac script, if it can't W get those, I don't think it'll fail. I think it'll just 404. No, it'll probably die. That's right, this section is short. Okay, so I want to explain what's going on here. We're creating a bunch of certificate authorities. Why would we do that?
All those Kubernetes components use TLS.
What's TLS?
So I think the difference in your certs is going to be, so when you're running the Mac one,
No, it may sound like I'm being facetious, but like I'm not very good at security. Like you need to get, like when you're communicating over SSL, is TLS the same thing or different or it's the latest?
people use it interchangeably, but TLS is actually what's been used.
Just next version of SSL. By next version, I mean the 10 SSL.
But it still runs over like HTTPS.
It's what UTPS.
Mhm.
Yeah, you can run non-HTTP over TLS. It drops in on top of.
So for many people, not many, this company that I worked at one point, they didn't do end-to-end encryption. Like it would come in the front door, and then they would all the stuff inside the data center would be HTTP, so that they could have security, like listen in on stuff.
The entire everybody.
So if that was your company's policy, like does Kubernetes only run if I'm doing all this extra stuff? And by the way, I'm just taking the second part of the lab that Kelsey has, and I'm just copying and pasting everything because I probably should have just switched over the top of my script. You're welcome to do that, but
The difference in your script is you took those Mac specific commands. It's looking for that you get.
or was it just that part of the top?
Yeah, with like your Mac script or whatever that you wrote before.
Oh shucks, I forgot to pay attention to what was going on. So does that mean everything between these machines is going to be encrypted?
This is just the
Just the control plane?
Kubernetes components themselves and the kublets of the worker agent. That stuff is all requires TLS, but by default, your application will be
Unless you set up.
Unless you set up like a in, cross, or use the same kind of neutral for less. There is a magic related project that was set up neutral to less called Istio. So that's probably like a whole other.
Sure. So when we're all done with this lab, which I just kind of copied and pasted everything from it because I had Mac specific stuff, you can do that or just change over this part at the top where it's W getting the Darwin stuff over to this part here where it's getting the Linux stuff for CFL. The point of this is to create all of these certificates. It sounds like these are going to be used by etcd, the Kube API server, which we're going to set up next. Or actually, the etcd will set up next. Kubelet and Kube proxy. What's etcd? I thought we were doing Kubernetes. That sounds like a completely different project.
It's the data store behind Kubernetes. So it's just a key value store similar to Zookeeper, console, anything like that. But that's where Kubernetes stores all the state information.
So you just, like, inside the Kubernetes code is doing a bunch of gets and sets to keep track of state so that that code can be more center part, like, I guess, what's the word? Transient, stateless, yeah. Ephemeral.
Unlike a normal database, it's HA by default.
Mhm. So does that mean that all my state is up in etcd? These are kind of ephemeral. I can lose any one of these. Actually, I can lose etcd, right?
Yeah.
One of them. What happens if I lose one of them?
So another thing, right, is so if you lose one of them, right, the data store as a whole. Another thing is like the whole Kubernetes control plane. If the whole control plane becomes unavailable, this code is like your application code is still running. It's just like the brains of scaling things up and down, finding your failure, those kind of control plane operations stop, and so if it's back up, but that's actually fine for a lot of clusters. Like it means like, okay, Kubernetes is down, so you can't do a deploy. That's bad, but it doesn't mean like nobody can load the site.
Would it be, for people that are already familiar with like Puppet Masters and Chef servers, be like losing your Chef server, but your site that makes you money is still up, right?
It's a little bit worse than that because there are things. So in Chef, like things don't generally happen continuously unless you're needing to change something. Kubernetes, there are things that you kind of expect to just change continually, like auto scaling and scales up and down. It's a schedule. It's scheduling moving it around, like health checking things, recovering from failure if I'm moving to other machines, and like if that stops, like you start to drift towards disaster. But it's not necessarily like HA is not necessarily like. But I mean, Kubernetes is good at all the components from HA. But if you think about doing this for like a Tesla program or whatever, don't like the complexity of the HA setup.
Mm-hmm.
In fact, like GKE is not HA. Box it on a single master in it. It's just a script so that it can reboot and come back up in like 5 minutes or less. That's it.
So that's one thing that I don't understand, and people have shared different concerns with me. This is usually mine. I've been afraid of Kubernetes and Mesos and all those things before because I don't feel like I can get that many VMs up and running on my machine, or I don't want to pay for that many cloud instances while I'm screwing around and doing it wrong. And once you start talking about like etcd, I'm like, well, I've got to have 3 machines, right? Like I can't even do any of this, right?
You don't, until you have one master and the NCE cluster, they're not really. So you're only paying for the orthodox.
Uh-huh.
So if you just get the master.
So is this running like a
Yeah, so
like kind of like
something
ECS, like where it's the EC2 containers type of thing for Google? Like, is it analogous to that? Like,
This is kind of the funky thing, right, about this kind of setup that we're building here. The Kubernetes control plane is hosted on the same set of nodes that are also running the workload. That doesn't necessarily have to be true. In GKE's case, for small clusters, the control plane is just a surface that they operate. All you run is the worker node that plugs into it.
so the etcd would be more like RDS in AWS, where you're just like, even though there's 3 MariaDBs or MySQLs back there, you're really just paying for the amount of transactions and the amount of space that you're doing or whatever type of thing. To a degree.
Pretty much. You have, you've only got a couple of work nodes, you don't need anything. The more work nodes you have, it's your flat. It's not from the work. So, that's the easy way.
That makes a lot of sense. That is my concern. So rather than copying and pasting, this one is either longer or something. Did anybody get through 2 that wanted to get through 2, or anybody not get through it, or anybody have other questions?
We're running script 2.
If you do run script 2, then you have to change the part of the top if you're doing it on Linux. If you're doing it locally, I think you were doing it locally, yeah, just run script 2. Locally on a Mac, right? If you're running it out here, you'll need to change this top line, which I'm going to do for 3. So what's everybody's favorite Linux editor? Nano.
Unless you have a new Mac. Unless you have a new Mac.
03. No tab completion? Bin. Linux AMD kube control. So if you are copying anything from here, note that you have to be on 0.7.1, or no, 0.7.0, not 0.6.1. When I tried to run that, I ran into an issue which is already on the thing, on the tutorial site. Okay. So I'm going to run 3, and then we'll talk about what 3 does. Three, setting up authentication. This one I don't know that I understood entirely. A TLS bootstrap token. Does someone want to take a stab at helping me understand?
So there's this bootstrapping system in Kubernetes that's supposed to make it easier to build the installation scripts. Basically, so kind of what we're doing, but more automated. One of the mechanisms to add is the bootstrap token. Bootstrap token system, which is basically like a password sort of that you give out to the worker nodes that lets them join the cluster. There's a lot of this things in Bootstrap and Puppet. So basically, like lets you bootstrap a new instance. And And the mechanism of how it works in Kubernetes is that Kubelet, which is the worker agent, takes that symmetric token that sort of is picture and uses it to authenticate. It's like, hey, I am a new node of the cluster. I need a real identity. And then it gets like it's a real certificate that's signed just for it. It comes in its identity. And then those tokens then can have like an expiration on them. So during a typical install when you're just running a cloud formation or a Terraform script, you can have a token that's only valid for 30 minutes. So spin up the cluster, everything gets the reliability, and then the system kind of sets itself in stone so that it's all locked.
That's pretty rad. So like if you're familiar with Chef, there's the client.pem, which is a .pem file. So it's one of those like, I don't know, 16 lines long and 40 some characters or whatever. This looks like it's just using your machine's devu random, taking 16 characters off of.
Yeah, so they're just little short random tokens that are copy and paste.
And then it uses that and throws it in a CSV file with a few other pieces of information.
Yep. So that's the piece. That's the file on the server that marks that as a valid token.
Then copies it out to all the machines, and then does some other things with it. Is that
This whole mechanism here is really designed for another tool that Kubernetes ships with Kubernetes. Everybody knows how to pronounce it.
all the above?
Yeah. So Kubernetes is a tool that sort of automates doing these bootstrap tokens and spinning up. So you just like Kubernetes init on the server, and then you copy paste Kubernetes join on the work. The point of this tutorial is not to is to dig into what's underneath the hood. What's underneath the hood is these random bootstrap tokens that are in the CSV file. That's exactly what Kubernetes makes too.
Fair enough. Anybody have questions on 3? 4 is where we bootstrap an etcd cluster. So what we're going to do is we're going to take, and this is something that's inside of the hardware scripts a lot, where he just iterates through the name of the machines in Google Cloud, and then does a G-Cloud Compute SCP, which is just like doing SCP to like a machine or whatever, which is something that I didn't realize when I started this. And there's, at one point, if you try to do this tutorial from start to finish, there's a couple points where he's missing that you need to do G-Cloud Compute SSH. Someone's logged an issue, it just hasn't been merged yet or whatever. So this is how you interact with it, which is actually coming from AWS. It's really smooth. Like, I guess I don't use the CLI right if they have that or whatever. But we're just going to take this script that does all these things, throw it on each of the boxes, and then I'm going to SSH onto each of the 3 boxes. But I'm not going to be able to do that.
You can from compute.
Because I have to do it from compute. In my terminal, I would have opened up 3 more and just ran the 3 commands simultaneously. And what this is going to do is set up etcd, which we've already kind of covered. Is important to Kubernetes, but it's not the Kubernetes that we're after. However, questions on what etcd is, or anything we've done so far, or suggestions on how to make this more fun for you?
What's that?
If you build with stateless processing nodes on like Amazon, a big chunk of what it is to enable each one of these processor workers to be stateless. That let's say client or customer in the real world interacting with that thing, and for some reason you get blown away, you have to have one move in place. So hosting the SE services because the 2 workers aren't holding on to their own state information. Each time they interact with the user, they're checking the SSD, saying, okay, what's the state of this session? I'm doing the process. And it gives you that continuity of processing user interaction in a way that in one of these worker views can just slide and get finished. Otherwise, you're going to have to learn that's why you already use it.
Kubernetes, you know, rather than the forum, it's 3 nodes, and every time Kubernetes makes a change, remembers that change by writing it to the backend, writes it to all 3, makes 3 copies, writes it to all 3 CD peers, and it waits for 2 of them to acknowledge it.
And then all the container hosts get that configuration.
Yeah, so the API server is kind of like a stateless almost like a proxy between the backend state that's an LTD and everything else in the system to this API server. So the API server is built into us, application, audit logging, validates the format and the versions of all the objects that are being stored. Fundamentally, that's kind of all it does. It doesn't sort of like API server by itself doesn't drive the system, it just stores stuff. And it stores it in its yeah.
It's got a lot more that's like a concept of a watch. So it is a Kubernetes code database kind of like
To know, like, it's thinking about things, professionals sort of running a cluster of 3 SMEs, like it's slower than running one SME. All the things that have to get acknowledged by multiple peers. So you don't scale it out for performance, you scale it out for
Another critical tool is with Kubernetes 1.6, they changed XCP data model, so gRPC formatted. So instead of just doing like it's VC2 class, and you can actually do the same map. It's a little bit different format to get that. Just
So from Kelsey's tutorial, the etcd lifecycle is not tied to Kubernetes, and we should be able to upgrade etcd independently of Kubernetes. For saving space, because we're already doing 6 VMs or whatever, you just decided to put etcd on where the kube control plane is running. It doesn't have to be there. And that's a really good point, that you don't have to have 3, I guess.
That may actually be the reason why I think that
Anybody stuck, or they're like, what the f are we talking about?
I just started. So
Just started 3?
that's what I was doing. I did one.
3?
Kind of doing.
I did 4, which was to bootstrap the HA etcd cluster. Couple things on that. Normally, I would just in my terminal open 3 of them. I did it pretty quickly. Is copy the script up there, then I SSH onto here, and then I just ran this like 2 or 3 times. And then SSH on here, ran this 2 or 3 times. SSH on here, ran this 2 or 3 times. So you see success. And then when you're done, you should run this, which is from the tutorial. And what you've got is that it'll say your members got healthy results. So that means your cluster is actually up and running.
Run 2 or 3 times.
I didn't put any weights in them because I didn't know where exactly to put the weights. When you're copying and pasting from Kelsey's tutorial 1 line at a time, there's enough time. When you're running a script where they're all back to back, so it was lucky that it was idempotent enough that I just ran it a couple times, because there's a couple things that say waiting along the way, and I spent time preparing for this, but I didn't spend enough time to actually write a strong script that would be error tolerant. So that's why I wanted to point that out, is to get this to work for me, I just ran it a few times.
Okay, that's cool. I've run it once. This attention, turned it to 0.
Maybe I didn't need to run it a couple of extra times. If anybody was at either B-Sides KC or the recent Sec KC talk, I learned from Kevin Shackleton that you didn't actually need to blow on the Nintendo thing. That actually could damage your machine. It really was that you needed to take it out and put it back in because there was a connection that needed to be made on your Nintendo. But all of us were like, we got to blow on the Nintendo cartridge to get it to work, right? Because someone else told me to do that. I'd do this thing where I took my shirt and I'd wipe out the inside. I always worked, right? Does anybody know? Is anybody young enough that they have no idea what I'm talking about with a Nintendo cartridge?
No, yeah. How do you know if SCD is running properly?
So that last command that is in there, that cluster help, should tell you that there are 3 help periods.
So you'll, this command here, like, so after you ran, you SCP the 04 script up there and you SSH on and run them all. Then when you're done, you run this command that tells you about your cluster.
It has to be the first one you ran it on, or any of
Yeah, it's on machine. Because my understanding, and someone in the room knows SCD better than me, is that they're peers. So you should be able to, like, you kind of direct your traffic. And this is what I understand, because I didn't put like a load balancer in front of it. Like, how does it, or did I? And I didn't know I did. Like, how's it going and getting that information and knowing?
You know, the 3 SEDs all talk to each other.
Uh-huh.
As a client from outside, you connect to one, it tells you about the other ones. And the clients are all smart, so they know, like,
With the command you're running there, since you're running from that first machine, which is your controller 1, controller 0, it's going to try to connect to localhost 2389. Something like that. That's just going to use a script that's there to communicate with the local instance of that CD and we put that.
That's true.
2379.
Yep, because I'd be running this one. Even if I wasn't running, if I was running like with the earlier stuff on my Mac, I would have been running this on one of the things I SSH onto, so it's just going localhost. Good point.
You can specify the peers and endpoints if you are running from the map to connect to that, but for this instance, it's just doing localhost connection.
Super rad. Okay, so that was 4. Great questions on etcd. Do people understand that better? Get on to Kubes.
you can't run it with a load balancer.
Okay, so now I'm going to exit out of those things. This would be, if you're running from a Mac, this would be like being on your Mac. I'm just on the console thing. Section 5, which is the Kubernetes control plane. I'm going to copy my 05 script up there. You think so?
Yeah.
Oh, wicked. Boom. 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 So then I, from those tabs, SSH onto the 3 machines. Oh, 1 or 0. Some people are serious about their zero index stuff. If I was writing this tutorial, I might make a different decision and start with 1.
I said KC back to 0.
Oh my. You can do different tabs, but it's very confused.
The command for the G-Cloud SCD scripts that won't load, that's run on one that's not logged into the right?
Yep, that one's just run from, think of it this way, it's from the directory where you have that script to secure copy it up there. Is it giving you problems?
I
that figured it. Sorry.
Oh no. This seems to have messed up every. If other people, if it works for you, rock on. You get errors on 4?
Order it out on me.
All right then.
Just some operation.
What do you think happened there?
We ran 4 on your local chain? Yeah. You have to SSH on. It shouldn't have let you go in. Oh, you even CD'd into scripts. I should have said this out loud. I thought it.
If it says that the script isn't there, and you're just copying and pasting from this README, that's by design. Because when you're running locally, you should be at the root of the GitHub checkout, and everything will be /scripts, and then the name of the script. And then when you SSH onto the machine, because you just secure copied it to just the root directory, then it won't be /scripts or whatever. So that particular one, you have to SSH on to each of those machines.
Okay.
So that's, it's G-Cloud, Compute, SSH, Controller 0, Controller 1.
So I just need to SCP those up then, those scripts.
Yeah, there's a loop to do that here. And then there's the SSH on, and then there's the run, the 04. Great question. I should have said that. It is 7:30. We need to clean up at about 7:45 or 7:50. This has been good for me so far. I've learned a lot from this discussion. I don't know if anyone else is. It sounds like people are having good discussions. Do we want to continue on getting this as set up as we can so you guys can play with it? Or do we want to just talk about what these other things do with all these smart people in the room? Or do we want to do a mix of both? Or you guys tell me, this is for you guys. Let's keep, all right. Let's, yeah, you can follow the instructions. You don't need to do that. You can continue to hack on that on your own. I will stop doing that. But let's talk about the next things through Kelsey's tutorial and how they're important. Yeah, feel free to just belt it out.
Oh, yeah. I mean, if you guys start running this at home or whatever on your own and have questions, just hit the Slack channel. We're all kind of in there about stuff. So.
Really great point. Yeah, jump on the Slack. I think if we get more people to do this and understand this, for the companies that are already doing this, that's more people that you guys can hire. And then for you individually, like the one thing I did want to bring up is like I see a lot of blogs right now that always refer back to who's that really smart guy that writes all the blogs from. He's a real smart guy that writes a lot of blogs. Martin Fowler.
Oh.
He did this blog where he talks about like sometimes it's not the right thing to do microservices. You're not there. You just build your monolith and make your money, right? And a lot of people are referring back to that. Like you don't necessarily like Kubernetes is too much for you, and that is absolutely true for a lot of things. Even Kelsey's been saying that in a lot of his tweets recently. He actually retweeted someone who wrote a great article, blog recently that said Kubernetes wasn't what we chose, right? However, I think that the biggest thing is like companies are paying a lot for this skill right now. There are companies that this is the exact right thing. They're doing really big stuff. They need to change out compute power quickly and stuff. So, the point tonight wasn't that everyone should switch over to this right away at their the company. It was like, let's sit down and actually get started and going with this. So the control plane, this is one where I want someone to explain this to me. We already talked etcd up. There's 3 pieces to Kubernetes. There's the API server, there's the scheduler, and the controller manager. Why is there 3 pieces, and what
Really bad names too.
are they? Because it seemed like some of the stuff they were doing.
Yeah, okay, so the first thing, you're right, start with Kubernetes. Kubernetes is the node agent. It's the thing that actually drives stuff. It talks to
like a system.
It talks to Rocket, there's global, which runs, basically operates the local node by asking the API server what to do. The API server, I've already mentioned, is sort of like the thing is responsible for the state of the system, even though really it's the API server presents the state of the system as an API. And everything goes, it's like a hub in the middle of all the kubelet's talk to the API server. When you run CTO on the command line, you're talking to the API server to add new objects into the database. The scheduler and the controller manager are both kind of similar. The controller manager is actually running a bunch of little things called controllers. Each of them is a little loop that just runs and looks at the state of the objects that are in the database. That represents sort of the desired state of what you want. So you want 30 copies of your application. Then it looks at the actual state, which is that there are 20 copies of your application running. And then there is sort of like a little piece of code that's responsible for driving the system towards the desired state. There's not actually just one piece of code that does that. There's like 15 of them, each responsible for one little aspect of the state. It knows how to like. So when you have a deployment is kind of like how it's feeling for pods. It has the expected, you expect 30 pods. Right now there's only 25 pods, so there's a piece of code in there in the control manager that's going to go create 5 new pods, put them in the system. But when it puts them in there, they're not scheduled. So then there's like another piece of code that says the desired state is that every pod is assigned to a node. Now there are 5 pods that aren't assigned to a node, so I'm going to put them on schedule. So the scheduler is kind of like source for pods that are currently unassigned and assigned to them. You can go through basically all the like continuous sort of processes that Kubernetes is doing are implemented as little pieces of code that are just used. One of the neat things to mention is like the whole system all the way back to etcd supports these options. In etcd, you can watch a key and say like, give me the current state of this key, and then whatever changes, tell me right away. So I don't have to find out immediately when something changes. The API server passes that capability through. So as a client of the API, you can also say like, show me all the unscheduled pods in the system, and as soon as there's a new one, tell me about it right away. So the scheduler, even though there's all these things that are little loops that might think of being polling, they're actually all linked into these watches, so they'll just like react instantaneously when there's something to be done. But then it's cool because basically if they miss something, they're always sitting there reconciling. So it's really hard for the system to get into too wonky a state because everything's always dragging back towards the desired state, which is it's not that dissimilar to like Chef. Chef does the same thing. Express your desired state and then every time you converge towards it. The difference is I think the set of primitives that Kubernetes is working with are more amenable to like facilitating that. Whereas in Chef, it's pretty easy. You end up with some process or some file that's not managed by Chef or whatever. Kubernetes, because everything is these container images and these containers that Kubernetes tells them to delete, they delete. There's a lot less opportunities for graft to accumulate. That's my experience in Chef. Yeah.
This seems orthogonal to what you're saying today, Tom, that like you thought it had deleted something, but the new one didn't work, and it was able to switch right back to the old one that was still hanging around.
Yeah, so there's a lot of concepts in Kubernetes from a user point of view that we haven't gone over at all.
Right.
One of the core concepts concept in Kubernetes is called deployment. And in deployment, there's these layers of concepts. You heard about pod, that's kind of the low level collection of containers. Then there's supervisory layers. There's a replica set and deployment. And what we saw, we use help. Help in the demo we saw at the beginning, we ran a little home chart and it spun up a whole slew of GitLab stuff. This is the benefit of Kubernetes. You can essentially run some canned stuff and you've got this huge set of all the stuff. We've been writing that for our software. We've been writing home charts with, which is kind of, it's the way we deploy to Kubernetes. And inside these home charts, we have all sorts of pods, deployments, stateless sets, services. These are all the concepts as a Kubernetes user. One of the cool things about the concept of deployment is you put health checks on the things that supervises. When I updated it, say a new operator, what it does is it spins up new pods, checks their health checks, and if the health checks fail, it doesn't bring in the load, it doesn't check out the load.
That's pretty rad.
It's really amazing. We actually had working for 3 weeks. Our site, this is all test, but like our test site is still up. So we finally got that stupid thing fixed. It was pretty awesome.
So when he did the Helm thing earlier, like those are, I'm assuming they've containerized that. He showed like what were like 6 different apps. There was like a source code thing. There was a Jenkins-ish thing. There was a Slack-ish thing.
Right.
That Helm command that so he probably spun up a dozen Docker containers to get that thing up and running.
Once more, so this guy, they were all networked together across multiple hosts. So if you go on a Docker, you see that Docker container communication is one of the more complicated aspects of it. Kubernetes does a lot of internal networking stuff to make container simpler. So that when you spin up a home chart, which essentially does a whole lot of Docker, yeah, you'll get. I think our production app is probably 40 different deployments, stateful set, 13 services. It spins up external, so we actually US concepts of load balancing, figure TLS, so all the internet points. Essentially push a home chart. Our entire production system about 5 minutes.
Have you used CloudFormation or Terraform or something similar to it?
So it's very different.
How would you make 1,000 times better or 10 times better?
It's a different layer, I would say. CloudFormation and Terraform, they're spinning up commands and very slow. What we do, we set up the Google version of Kubernetes, and then we just tell Google to auto-scale. So when we put every container of Kubernetes needs to have RAM and CPU limits on it. That way it knows whether it's going to go out of the box. So we have RAM and CPU definitions for every single application. And when we push out new test environment, it takes 0 time to go to the API. And the API suddenly gets 50 fingers to start up. Tries to schedule the boxes. It triggers out CPU limits, CPU errors, and then Google notices that within about 10 seconds, it starts kicking off.
a lot of this is happening because people started to like what it is, but don't like the experience that they're having with the native instances. What you're describing is being able to spin up these Docker instances, Kubernetes instances, your host VM is already there. So each time one of these gets created with essentially the same container profile, it's just duplicating a pointer to what's already physically in memory on that host computer or host OS. And that's why these can get instantiated so fast. And you can do this on other hypervisors, but the experience that you're having here is largely but that's, I just want for that pointer memory was enabling faster response.
I mean, so there's a couple of things. So sometimes there's really in that case, it's a matter of confirming the documents before we start the process. That is happening in a second. If there's no rule, then we have to pick up Google or Amazon or whatever layer. At that point, Amazon uses them. I think it takes about a minute to start up with them. Google uses so our current system, what I do is I have a minimum and maximum cluster size, but I don't think about boxes. Just put work on it, unless there's more containers, just goes up. Servers, so the cost is all based on more servers. Yeah, so spinning up is about a 10-second operation. Spin down it's got enough space. This is an option.
May I have your attention, please? The Corinth Library will be closing in 15 minutes. The computers will shut down at 8. If you need to print or save your work, please do so at this time. If you need to check out materials, please use one of our checkout stations. Thank you.
Which is a good, I do want to bring this up, and I want to make sure everyone's listening and they realize it. You got that $300 credit, right? You are never going to get mad at me if you get charged money, because I'm telling you as loudly as I can in a library, there is a cleanup script at the end. There's a cleanup script at the end of the thing that you've been copying and pasting from that's going to shut down everything that you did. So I do suggest you try to get to the end of that tutorial, and when you're done, you shut it down. To give you an idea on cost, I have left mine up for the last 2.5 weeks, and it's cost about $100, right? So if you leave this up for the next 3 or 4 months, I'm not going to give you $500. It's not going to happen. So cleanup script is here. You can run the spin-up script, I believe, at any point, and if the things aren't there, it will just delete nothing, but it will delete the things that you've done so far.
Just throw it out there when you're on the trial account, we credit, basically everything, all of this sort of auto charging you until it says, hey, you got credit, you want to upgrade your account. So you don't get like the automatic auto charge, essentially just like shut itself off once you get done.
Strange things happen in the cloud. I put an alert in there to tell me when I'd spent more than $10. Didn't happen. Well, it's true. Right, but I wanted to know if, like, you know, I'd use more than $10 of credit. I thought that's what I was doing.
You probably had already used $10 credit.
That's true.
If you're looking for like a cheap way to experiment with Kubernetes, you can run it locally in Minikube. It's a typical environment. GKE can run it preemptible instances. You can run it on like a small node, variable, and it costs like $1 a day.
Brad, Was this to run Kubernetes, the thing you posted?
So there's two parts. This was more just a diagram illustrating kind of different components. And if you want to just a picture of what Kubernetes looks like, I'll just point that should help. The other thing I was going to mention is just kind of putting something out there for choosing these cards out. There's
I did the same, I posted in Slack, and I was like, I posted it, and as soon as I did, Slack highlighted that was a link. And I'm like, oh, maybe I should click on the link. And sure enough, it pops up and it says, enable. And it's like, yeah. But the ear was like this long. It was like, sorry. It's like, oh, this one was a 5. Didn't even bother. And the rest of them
So one other point. Tonight was by no means perfect. Please let us know if we should not do this kind of thing again, if we should do this kind of thing, how we can do it better, or whatever. Someone else lead it and sit up here and try to get a large conversation going. You totally can do that. You can rely on me to do that. It doesn't matter. But there's things that were great about tonight to you. There were things that sucked about tonight. Let us know that, and we can. I like this format. Some people don't. I don't know.